Hello and welcome to this tutorial where we will be building our own AI green screen, right? So we'll be able to take a video, we'll say, hey, this is the thing I want to keep, and then we will automatically have it like effectively green screened out. So, before we begin, what tools will we be using? We'll be building this off of Meta's Segment Anything model, or SAM2, right? And so we're just going to be using this model and we're going to be using it to automatically like detect what are the things we want to keep and what are the things we don't want to keep. And we're going to be having NumPy, Torch, and Pillow for like support with actually handling images and whatnot. And we're going to have Blender for the final stitching, right? So, and that's it. That's everything we're going to use. It's a very simple project. So, what is the architecture of this project? This project, what we're going to be doing is we're going to have the input video. We're going to split it into a bunch of different frames. And so we're just going to be using FFmpeg for that. We're not doing anything fancy. Then we're going to feed them all into SAM2, right? Then it's going to output the frames that are like, hey, here's the actual like cutout of all the stuff, of like, hey, here's the stuff you want. And then when we're putting that into Blender for just the final stitching, and then we'll have a final video and clip in like MP4 or like, you know, whatever format you want, AVI, you know, just pick the format. It's a Blender, right? So now let's get building. Okay, so now what we have is we're going to start with the file we want to do. So I have the input video, and the input video here is just a webcam from the previous section, the one with the slideshow. And so now I'm just going to make a folder for all of the like input frames, because we have to split this up into individual images. And of course, it doesn't make that much sense to like do that as part of the as part of the Python code. So we're just going to use FFmpeg, right? We're going to take FFmpeg, we're going to have the input video as input video, we're going to have it, we're just going to export it as frames, we're going to start the 0th frame, and then we're just going to put it in, and we're just going to have, you know, just the frame number, and it's going to have like 5 digits, which is probably a little bit overkill, but like, you know, it is what it is, it doesn't actually particularly matter. And so we're going to run the FFmpeg, it's going to run across the entire video, and so the video is roughly 2600 frames, and so there you go. Yeah, 2,561 frames. And so there's the encoding, and so we can just go into video. You can see all the frames. Cool. Now we're going to set the Python environment, right? So Python 3 VM, and I'm going to call it Greenify, right? It's just a name to indicate the environment. And so we're going to activate it, right? And then we're going to install all libraries, right? So obviously we're installing the SAM2 library. We're going to be installing NumPy, Torch, Matplotlib. We're using Matplotlib just to have like displays during the time, and it will, you know, work like that. We are installing Pillow, and we're also going to be installing Transformers because that gives us Hugging Face Hub, and that's what we need to actually download the model. We don't necessarily need Transformers, but like if you have it on your system because you've been doing stuff with it, it's like really easy to just throw it in there as well. And then that should be everything. So we're going to install that. And it's going to go, it's going to install all the stuff. And it's installing. Give it a little bit of time. Since we're installing a lot, it's actually going to take a little bit of time to install. But after that point, we should be able to actually start writing our code. This is going to be a very small project. It's only like 100 lines-ish. It's nothing too fancy. But it is, you know, it does one thing and it does it pretty well, you know? So now we wait. Give it a little bit of time. And so yeah, this is entirely because we're installing a lot of packages, as you can see. Like we're installing a ton of packages, and to be fair, this model is kind of built on top of a ton of extra research, and we're only really using it as like an API layer to just like do a bunch of segmentation. We're not really using it as like, you know, one of the as like doing research on it. We're just using it as a model, and there we go. Now what we're going to do is we're going to make our main.py. Cool. So in here, what we're going to do is we're going to start by doing all of our imports. Right. So we're importing Torch, we're importing SAM2, the video predictor, because we're feeding it individual frames of video, but we're going to be like using a mask to like forward it through. We're importing Pill, so we can actually import the images, and NumPy, Pyplot, OS, just so we have some utilities. So now I'm going to be copying some functions straight from the documentation for SAM2, and this is from their notebooks, and this entirely is, it's just debug of like, hey, how does the mask look, how does the point look, like all of that. Cool. Now that we have just some of the debug stuff and like just all of that set up, now we can get into actually writing the script. So first we have to load the video. So again, I put all the images into the video folder. We get the frame names, and so we get JPEGs, right? And so we get all the frame names and then we sort them, right? So now we know the order. Then we're going to set up the predictor, right? So there's a predictor. It's from pre-trained, SAM2, high error large. And so we're using the biggest model. Use a smaller model if you have much less memory, but we're using the biggest model here because, you know, this is a very small video. Obviously, if you're doing larger videos, you want to be using a smaller model, or potentially start with a large model and then go down to a small model after a few frames, but yeah. And then for points, so for this video, I've actually pre-calculated some good points right here, and that's, like, I'll show you how to find these points once you actually run the script, because all it is what the point is that just saying we want this part of the image, right? And so we want to mask that part. But of course, I have 3 points here, and that's because if, for example, I put a point on, say, my head, right? Maybe it'll only say I'll mask your head. So I have another point in my t-shirt, right? And so I have multiple points here just so I can get everything, right? So one of these points is in my head, another one will be on my t-shirt, another one is on the headphones. Though, of course, for this video, I think they're not exactly there because these were computed previously, but like, it's close enough to the point where it gets my whole body. Now, we're actually going to run some inference, right? So first, we're going to set up the Torch inference mode, and we're going to initialize the state. And so in the state installation, we're giving it the path to the video directory, but what we're also giving it is we're also telling it, hey, make sure the video is actually on the CPU memory, not GPU memory. Because the problem is, if you put the video on GPU memory, this 1.5 minute video will take like 30 gigs of VRAM. And like, unless you have a server grade card, 30 gigs of VRAM is just way too much. So we're offloading it to CPU. My laptop has 64 gigs of RAM and it can fit nicely in there. If you don't have that much RAM, switch to a smaller model, and then you'll have access to more memory. And so yeah, we're adding the points to the state, and then we're just going to be displaying like, here's the point and here's what it thinks we are doing, right? So yeah, I accidentally pasted, right? Cool. Now from here, we're just gonna run the actual inference on every single part of the video, right? And so again, this is the thing that actually does the inference, right? And so here is this part, and we're just setting video segments as a dictionary, and we're just looping through. We're just propagating our mask that we generated on the first frame throughout the entire video, and we're just going to be generating it for the entire video. Cool. I'm also moving everything to the CPU and converting it back to NumPy, because at the moment we're not dealing with GPU stuff, Torch becomes less necessary, so we're just going to be doing that. Cool. Amazing. Now let's create the now let's actually do the saving of the images, because we have the images, they're now in there. Now let's actually save them. And so this is, you kind of think this is like the main, just saving. And so output directory, I'm just calling it output, and we're just going to make it if it doesn't exist, right? So that's what exists okay does. If it exists, cool, we're not making it. If it doesn't exist, we're just going to make it. Now, for every frame we have, so frame names, which is our just sorted array of all of the files, we're going to open the original image, right? Because we're trying to do green screen. All SAM2 does is it gives us a mask. And so we're going to use the mask to do green screen. And so if it's not in RGBA, because we're trying to set the alpha channel, right? Because remember, all images have RGB and A, where A is the alpha channel. We're going to set the alpha channel to 0 if it's not in a mask and 1 if it is in the mask. And if it does, doesn't, we just give it an A channel, and we just convert it to an NumPy array. And then the masked array is the masked image, we're just going to copy it, and then if the frame is in video segment, so if there's an error, we don't do anything, but like if the frame is in there, we basically say, hey, so first we reshape the mask, right? So it matches the same dimensions, because 1920 by 1080. Then what we do is we effectively change it into a 40, because it's RGBA, right? So here you can see it's only one dimension, but now it's RGBA, and then we just multiply it with the masked image, and then we effectively masked the image to only contain the stuff we want it to contain. And then we convert it back to a pillow image, and then we just save it, right? And every 1,000 frames will show us the actual image just to see that it's working and whatnot. And we can see all frames processed and saved. Cool. Now let's actually run the code, right? And so of course there might have been some errors in the copy paste, but I doubt it. And so yeah, it's going to load the entire JPEG, all of the frames, so 2,000 frames, loading at 30 per second. So as you can see, it's going to take like a minute. And so yeah, when it's done loading the frames, it will set up the inference pipeline, and then it will show us, hey, here's where your points are and like where the mask is, right? And so obviously our first frame won't actually be that good. How SAM2 works is you give it one frame, and then at least the SAM2 video mode is you give it one frame, you give it the points on that frame, and then when you go to the next frame, you give it the mask that it previously generated. And from the mask and from the new the old image in the new frame is going to generate the mask for the new frame based on the old frame. So there might be some noise in the first frame, but after that point, the model will understand what's actually kind of going on, and then it will effectively denoise itself. And so, yeah, and so the first frame's not going to be that good, but the next frames will be a lot better. And so in 30-ish seconds, what'll happen is it will finish loading it, and we'll see the first frame, and then after that, it's going to generate it all. I'm going to let that generate. That's going to take like 10 minutes, and I will get back to you guys when that's done. But for now, it's just another 15 seconds. We can wait a little bit of that time. Cool, that's done now. And so we should see, there's the thing. Here's the first frame. As you can see, the points are not exactly on the stuff, but and you can see some of the noise of hey, it's not actually detecting the entire headphones, but it'll fix itself over time. Cool. I think this is a good mask of me. Well, good enough. We'll close it, and now it's going to propagate through the entire video, and as you can see, it's going to take 10 minutes. I will see you guys when that's done. Okay, so now that the code has finished running, we can actually check the results. And so to do that, I'm just going to open up Blender. Right, Blender, you can just use it, and I'm just going to add in all of the images. Image sequence, code, output. Here's our output. We're going to add them all. And so as you can see, the first frame is not super good, but after that point, it's become very good, right? It's a really good green screen. Now, of course, there's obviously going to be some issues, right? Because when it doesn't know what to do, that middle area in between my headphones, but other than that, it's actually a pretty good green screen effect, and it's very easy to do, and you can also control it. You can be hey, I only want you to do my head and not my body. So you put a point in the head, in the head area, and you put a negative point in the body, and then boom, it will not do the body, it will only do the head. And so you kind of have a lot more control there than if you just had a green screen. Then you have to get a green t-shirt if you wanted to only have your head, or or you'd have to do a green face mask if you only want your headphones or whatnot. And it's just and if you only want your glasses, it'd be basically impossible, right? And so it's this is just a much easier way to do things, and now you know how to do it. Thank you for watching. I will see you all in the next video.